Greetings! We're going to do a short recording here on problem 16. Solve each exponential equation for x, show complete work, and check your answer using a graphical process and a numerical one. Write your final answer in both exact form and rounded form, 3 decimal places. Okay, so let's take a look at the following of these. So first one here, we've got 8 minus 2 times 6.2 to the x equals negative 10. First move, we're going to subtract the 8 from both sides. So this is going to give us minus 2 times 6.2 to the x is equal to a negative 18. That was subtracting 8 from both sides. Then we're going to divide both sides by negative 2, and that'll give us 6.2 raised to the x power is equal to a positive 9. Now, I need to get the x out of the exponent position. So you're calling that. I'm going to go ahead and use the common log to do that. So using the common log, I'll take the common log of both sides. And so that would be log of 6.2 to the x is equal to log of 9. And then that puts the x out front. Okay. So that gets me x times log of 6.2 is equal to log of 9. Okay, so let's come over here because I'm running out of room. And so that tells me that x is equal to log of 9 divided by log of 6.2. Okay, now they want us to validate our answer a couple of different ways. One way they want us to do that is by doing a graphical technique. So let's go ahead and do that one first, and then we'll take a look at a numerical way of verifying that. And so the way we have to do this is we've got to go into our y equals menu of our calculator. I'm going to type in the original equation. Don't put any of your substeps in. You've got to go with the original. And so they typically want us to use the intersect routine. So I'm going to use the left-hand side of 8 minus 2 parentheses 6.2 raised to the x power. That's going into y1. And in the y2, I'm going to put in a negative 10. Okay, now I can try a zoom standard here, which is a typical graphing window that you would use, but we would soon discover that that's not going to do us much good. I mean, let's go ahead and just give it a go and see what happens here. And there is my exponential, and I'm barely seeing that point of intersection. So it's not a horrible graph, but I would really like to see that intersection point a little more clearly. So I'm going to adjust my window here and get a little more of the y min. So let's go to like negative 15 on the y min. And if I do that, notice that adjusts my viewing window so that point of intersection is much clearer. Okay, so let's go second calc. And from the calc menu, we see that our friend here is intersect, which is 5. And now I'm going to get my little jumping frog down as close to the point of intersection as I can. And I'm going to say first curve, second curve, best guess. And I get the following numerical approximation. So let's come over here and let's put a sketch of that onto our homework assignment. It's going to look something not quite unlike, but similar to this, where that's the x-axis, that's the y-axis, and there's our point of intersection right there. And from the calculator, it looks like our point of intersection is about 1.204 for the x value. And, sorry, I didn't want the 0 first. I wanted 2 there, didn't I? 204. There we go. 204, and the y value was negative 10. We don't really need that. It's only the x value that we need here. Okay, so to check this with the numerical one, what they mean by that is I've got to go in and evaluate those logarithms. And so I can see whether or not my calculator agrees from the graphical standpoint as it does with evaluating the logarithms, okay, on the calculator. So we're going to take log of 9 and divide that by log of 6.2 and hit an enter, and the crowd goes crazy because that is also approximately 1.204. Okay, so that means pretty good chance that I got it right. All right, so let's go pick up a couple more of these, and then I'm going to get another video going. So this one, we're just going to grab the logarithm right away because my exponential is isolated. So this is log of 3 to the x plus 2 going to put all of that in parentheses to indicate that that's my argument of my logarithms, and that's equal to log of 18. Don't forget to do both sides by the logarithm. You're taking the logarithm of both sides. Okay, so then this gives me what? This gives me x plus 2, again in parentheses, times log of 3 is equal to log of 18. Okay, so then let's divide both sides by log of 3. Think about that as being a number, and that gets me x plus 2 is equal to log of 18 divided by log of 3. Okay, and then last but not least, let's come on up over here. It's going to be x is equal to log of 18 divided by log of 3. And then I'm going to subtract 2 from it. So that's my exact answer, okay? Let's make that look a little more like a log there. There we go. All right, so let's go do the graphical solution. So in the graphical solution, go back into our y equals, clear out everything from the last problem, and we're going to do the same thing. We're going to put the original original left-hand side into y1 and the original right-hand side into y2. So that says x plus 2 is my exponent on a 3, so that's 3 raised to. If you're an old dog calculator like mine, do not forget the parentheses. You need to put in the x plus 2 to make that work right. And then in y2, we're going to have an 18. If you're on a newer calculator, it kicked you up into the exponent position, and it'll let you type the x plus 2 in there just straight up. Okay, let's go ahead. We don't know any better. Well, I do know better. I'm going to have to change my window. I can tell you that already. If I do a zoom and a standard here, I won't see the horizontal line. One of the reasons we teach you the equation of a horizontal line is just for being able to use this technique. So let's use y min again of a negative 10. We'll go back to that. But I got to go up to y equals 18, which is a horizontal line going through 18 in the y-axis. So I know I need to go to at least 20. Actually, let's go to 25 to get enough of the y-axis to see the point of intersection. So let's press graph. Yeah, bada bing, bada boom, there it is. There's my point of intersection. So to get the intersection on the calculator, you hit second calc, go to number 5 for intersect, first curve, second curve, best guess. And so coming in here and making a sketch of my, whoops, I want to move my axis down just a smidge here, of my graphical solution, where this is the x-axis, this is the y-axis. And we see that, well, let's go back to our graph here for just a moment, and we see that we've got this increasing exponential that comes up and goes boom and crashes through our line y equals 18 right there, which is at about 0.6309. So 0.6309 is the magic x value we're looking for. So let's go take a look and see what log of 18 divided by log of 3 minus 2 is. So get out of here. I was going to do log of 18 divided by log of 3. And then we're going to subtract 2 off that. And look at that. So by the way, the intersection routine stored its value that it got in the variable x. So if you just type in x and hit an enter, you'll actually see that the intersection routine agrees exactly with the decimal approximation that we got by hand. Okay, so let's come over here and put our decimal approximation on here, and we see that that was what, 0.6309, just like we saw with the graph. Okay, all right, I'm gonna go a little faster. I'm not going slow right now, obviously, but I'm going to pick up the pace on E and D here, okay? So this is 2 to the x minus 2 is equals 6 goes into 24 4 times, right? And so this is going to be logarithm base 10 of 2 to the x minus 2 is equal to log of 4, which says x minus 2 is equal to log of 4 divided by log of 2. Okay, now that's doing it using logarithms. Let's finish it up over here, and that gets me what? X is equal to log of 4 divided by log of 2 minus 2. Okay, all right, now interesting thing here is we actually could have done this a different way. So I just want to show that to you really fast, kind of why I went so quick with the first version here, is we could have written this using the fact that if I have the bases the same, the exponents have to be the same. So 2 to the x minus 2 is equal to 2 squared, because that's what 4 is, right? Now notice the bases are the same. And since my bases are the same, then that means the only way that could be true is if the exponents were the same. So that tells me that x minus 2 is equal to 2, or x is equal to 4. Okay, so let's go do the calculator part first before we do the graphical solution this time. And let's see if that actually turned out to be true here. So if I take log of 4 and I divide that by log of 2, and then I subtract 2 off of that, I get back 0. Because I'm a dork. This is a plus. Try that again. One more time, Mike. Let's go back to the calculator here. That's what I get for going fast. My mistake. Yeah, but some of you are yelling at me already. Going, Mike, you should have put a plus in there. There we go. Now we get the 4. Perfect. Okay. So if we go back to our y equals and do this from the graphical standpoint, you're going to put in 6 parentheses 2 raised to the x minus 2. Actually, I think I want to do this type it in a little different than it looks. It's going to be easier if I go 6 times 2 caret parentheses x minus 2. That's going to be a much easier way to type this in, and I'll save myself a few parentheses that way. And then down here put in a 24. So again, I know my y equals is on y2 is equal to 24, which gives me a horizontal line going through 24. So I'm going to bump this up even bigger in my y max and go to 30. Here we go, got our point of intersection, so we're going to do a second and a calc. Number 5, first curve, second curve, best guess. And boom, we got x equals to 4 again. Okay, so we want to give a somewhat accurate sketch of that here also. And we see that x was equal to 4 here. Put an x and a y in there so I know which one was the x-axis and which one was your horizontal line. Okay? All right, one last one on this one. That gives me what? 4 to the 2x is equal to 68 minus 5. I'll go a little slow with my arithmetic here since it's late and I seem to be not doing so great with that. So let's make sure I can do that. So we got 68, subtract 5 from there, and wow, that gives me back 63. So this is going to be log of 4 to the 2x is equal to log of 63. All right, so I'm kind of already out of room, so let's come over here. And so what's that going to be? So that's going to be 2x is equal to log of 63 divided by log of 4. And then last move is going to get me that x is equal to log of 63 over 2 times log of 4. Okay, so I'm going to let you actually do the rest of that on your own. Go ahead and do the graphical part and the numerical part. I think I've got a pretty good run on that with the previous 3. So it's getting a little long. I'm going to stop this one and get on to the next one.